Hello there, and welcome to the Sleepless Scientist, a quiet place in the cosmos where your thoughts can unwind and knowledge becomes a soft lullaby for the night. Tonight's journey will take us into the mystery of the universe's speed limit, the curious boundary set by the speed of light. But before you settle in and get cozy, I'd love if you could take a moment to like this video and subscribe. Only if you truly find these quiet explorations enjoyable. And when you're ready, leave a comment to let me know where in the world you're listening from and what time it is for you right now. It's always such a joy to see all the places we gather from, each in our own little slice of time. Now, feel free to dim the lights, maybe turn on a fan for a soft background hum, and let's gently begin our journey into this question together. And if your mind begins to wander, that's perfectly fine. Let it drift. We'll still be here, quietly unfolding the story. Imagine for a moment a flashlight in your hand. You press the switch, and instantly a beam stretches into the night. It feels immediate, as though light leaps from the lamp to the world without hesitation. But in truth, light travels with a speed, an astonishing one, close to 300,000 kilometers each second. To put that in softer terms, in just a single heartbeat, light could circle our entire planet more than 7 times. It is difficult to imagine something so quick, and yet in physics this speed is not just fast, it is final. It is the boundary beyond which nothing, no message, no matter, no whisper of gravity can pass. When Albert Einstein shaped his theories of relativity, he discovered that this cosmic pace is not just a property of light, but a kind of woven thread in the fabric of reality itself. The universe has many rhythms, atoms vibrating, hearts beating, planets circling, but above them all, there is this steady drumbeat, the speed of light, keeping time for space and for time together. It is the ultimate speed limit, written into the structure of existence. Now, to most of us, this might sound like just a number, 300,000 kilometers per second. Or, if you prefer a smaller picture, about a foot of distance every billionth of a second. It is something measured, something recited in textbooks, much like knowing the boiling point of water or the height of Mount Everest. It feels arbitrary, as though the universe simply shrugged and said, "This will do." And yet, perhaps it is not arbitrary at all. Perhaps it is a memory. Think of the universe as a being that once was young. In its earliest moments, it was a roiling ocean of energy, hotter and denser than anything we can recreate on Earth. Out of that firestorm, particles formed, forces separated, and the laws of physics as we know them settled into place. In that settling, perhaps the speed of light was chosen, not by preference but by necessity, frozen into reality like the cooling pattern on a piece of glass. What we see today, every time we switch on a lamp or watch the stars, may be the echo of that ancient choice, a cosmic memory still guiding us. We can test the speed of light with clocks, lasers, and precise instruments. We can measure it to more decimal places than most of us would care to count. But behind those numbers lies something stranger, the suggestion that this limit is not just about light at all. It is about information itself. No signal can travel faster. Even gravity, racing across the void, respects this boundary. If the sun were to vanish, thankfully only in thought experiment, we would not notice instantly. Earth would continue to circle an empty spot for about 8 minutes, only then feeling the absence. Light and gravity both carry news of the cosmos, and they both keep to this same rhythm, this same limit. In everyday life, you can sense echoes of this rule, even if you have never thought of it. When astronauts talk to Earth from the moon, there is a delay, a pause between question and reply. It is only a second or so, but it feels uncanny, like talking on a phone with an echo. Stretch the distance farther to Mars, and the pause can grow to minutes. Imagine asking a question, then waiting in silence before the answer returns. The universe enforces patience, gently reminding us that even our fastest signals cannot outrun its memory. Some scientists call the speed of light a fundamental constant. That phrase sounds very official, but really it just means a number that appears everywhere in the equations of physics, never changing. It links space to time, electricity to magnetism, energy to mass, and yet in a way, that phrase, fundamental constant, can feel cold. What if instead we imagined it as a story, a preserved whisper from the beginning, carried through all of cosmic history? Think of DNA in your body, the shape of your eyes, the tone of your skin, the way your hair curls, all are written in a code, carried through countless generations from ancestors long forgotten. You do not choose it, you inherit it. The universe may work in a similar way. Its constants may be the DNA of reality, inherited from the very birth of time, and the speed of light might be its most visible gene, the one we notice most often because it governs so much of our daily cosmic experience. When you glance at the stars, you're not just seeing tiny dots in the dark, you're reading memories. Starlight takes years, centuries, millennia to arrive. The light from Sirius left when you were still young. The light from Andromeda began its journey before humans learned to write, and the light of galaxies at the farthest reach left when Earth was not even a dream. Light always carries a story, and the speed it travels at is part of that story, a reminder of how information threads through time. So tonight, as you let your body sink deeper into rest, consider the quiet rule that shapes the cosmos. Nothing may go faster than this pace. It is not merely an obstacle, not a wall, but perhaps a memory, a rhythm set down when the universe was still new. The trail of clues leads us gently into the thought that constants may be more than numbers. They may be fossils, carried in silence, waiting for us to listen. And from here, our story opens into the wider question. If the speed of light is a memory, what else might the universe be remembering? If we follow the thread a little further, we begin to notice something almost paradoxical. Light feels so quick, so unstoppable, that calling it a limit seems odd. Yet this pace is not simply one fast runner among many. It is the finish line, the outer boundary. No matter how much energy we add, no matter how clever our machines, nothing with mass has ever been coaxed to outrun light. The universe seems to have built in this boundary, as though it placed a speed sign at the edge of existence, quietly insisting, this far and no faster. Why should this be so? The answer lives inside Einstein's theory of relativity, but we can keep it soft and simple. Imagine space and time not as separate things, but as a fabric woven together. Light speed is like the tightness of that weave. If you try to move faster than that, you're not just breaking a rule, you're tugging at the threads themselves. The fabric does not permit it. So, the number is not arbitrary, not like a rule made by humans. It is the very architecture of reality. To picture this in a gentler way, think of ripples on a pond. When you toss a pebble into still water, rings spread outwards. You might imagine swimming faster than those ripples trying to overtake them, but you never can. The ripples move at the speed of the water's nature, and you are inside that nature. The speed of light is like those ripples, only instead of water, it is space-time itself that ripples, and we are swimming within it. Everyday life offers reminders of this quiet rule, though we often overlook them. Think about phone calls that cross oceans. The voices feel instantaneous, but in truth the signal is riding on light, darting through fibre optic cables and satellites. It is so fast we cannot notice the travel time. Yet, stretch the distance farther, and the rule becomes harder to ignore. When astronauts spoke from the moon, there was a tiny pause, about a second between question and answer. It was long enough to feel strange, like speaking across a canyon where your words echo back. And with Mars, the pause stretches to minutes. You could ask a question, make a cup of tea, and only then hear the reply. That delay is the universe quietly reminding us of its boundary. There's another way to see this limit, and it involves time itself. Relativity says that the faster you move, the slower your time flows compared with someone at rest. Push a spacecraft close to the speed of light, and its clocks tick more slowly, its crew age less quickly. Yet the closer you get to light speed, the harder it becomes to add more. It is as though the universe protects the boundary by redirecting your effort into bending time, not into moving faster. So even in thought experiments, where imagination allows us to chase impossible speeds, we always find ourselves slowed and turned back like waves hitting a shore. To soften this further, imagine a child running on a merry-go-round. At first, they move easily, but as they run faster, the floor beneath tilts more sharply, pulling them inward, demanding more effort to stay on track. There comes a point when they cannot run faster without being pulled into the centre. In a similar way, nature channels every attempt to exceed light's pace into changing the flow of time and space instead. The limit is never crossed, but reality itself bends around the effort. Some may wonder, if nothing can travel faster than light, what about the universe's expansion? After all, distant galaxies slip away from us so quickly that their light will never reach us. Isn't that faster than light? The answer lies in perspective. Those galaxies are not racing through space. It is space itself that is stretching. The rule applies locally. No object moves through its immediate space faster than light. But the fabric itself can stretch, and as it does, galaxies drift apart, carried like dots on a balloon being inflated. This distinction is subtle, but it shows how the speed limit shapes not only movement, but the very way we describe cosmic growth. It is tempting to think of the speed of light as a cold number, carved into equations, sealed into textbooks. But perhaps we can imagine it as a kind of rhythm instead. The universe sings softly to itself, and this is its tempo. Particles, forces, even the reach of gravity dance to that same beat. When we say nothing can travel faster than light, we're really saying nothing can dance off beat from the universe's music. The song has one tempo and everything must follow. Think too about how this rule shapes our view of time. When you look at the night sky, every star is a memory. Light has travelled at its fixed pace for years, sometimes for millions of years before meeting your eyes. Because of the speed limit, we never see the present of the stars, only their past. Light arriving from the Andromeda Galaxy began its journey about 2.5 million years ago, when our ancestors still chipped stone tools. In this way, the boundary creates beauty. We live in a gallery of cosmic history, painted not in oils but in photons, each brushstroke placed long before we existed. So what seems like a hard wall, the speed of light as a maximum, also becomes a window. It gives us a past to gaze upon, a record of what has been. If there were no speed limit, if light reached us instantly, the sky would not tell stories. We would see only the present, bare and unlayered. Instead, the universe grants us a kind of memory every time we look up. The limit is not only a rule, but a gift. From here, the story opens into a curious thought. If this speed is so central, so universal, then why this particular number? Why not slower or faster? Did the cosmos simply set it down at random, or does the value itself carry memory from the dawn of everything? Perhaps as we drift into the idea of cosmic echoes, we will find that the limit of light is not a ceiling at all, but a preserved whisper of the universe's own beginnings. As our quiet exploration now turns toward deeper reflection, we can imagine the speed of light not just as a physical number, but as something far more poetic, a memory. The phrase might sound strange at first. Memory is something we usually reserve for people, or perhaps for animals who recall their paths and their kin. But nature itself seems to carry memories. Trees carry them in the rings of their trunks. Rivers carve them in valleys. Our own bodies carry memory in strands of DNA. Why then should the universe not also hold its own memories, written not in photographs or words, but in the laws that shape everything we see? To soften the thought, imagine holding a seashell to your ear. You hear a sound that resembles the ocean, though the shell has not contained the sea for millions of years. It is not the ocean itself, but an echo, preserved in shape and resonance. In the same way, the constants of physics might be seashells of the cosmos, carrying echoes of the earliest tides of reality. The speed of light could be one such seashell, its fixed value a preserved sound of the Big Bang's first whispers. In the first moments after the universe began, everything was compressed into a density beyond our imagination. It was hot enough to melt even the idea of matter. Particles were born and destroyed in the blink of an eye. Forces that today are distinct, gravity, electromagnetism, the nuclear forces, were entangled, perhaps indistinguishable. As the cosmos expanded and cooled, these forces separated like voices in a choir finding their own notes. With that separation came the laws we know, the strength of gravity, the charge of the electron, the rhythm of light. Each one may be a trace of how the cosmos settled into itself. We often think of constants as permanent fixtures, as if they were absolute truths existing outside time. But what if they are more like scars? A scar on your hand tells the story of a childhood accident, long past but still present in your skin. Constants may be scars of the universe, carrying silent stories of collisions, coolings, and choices made in the first seconds. The speed of light is not just a wall to motion, but a mark left by the moment when the universe first defined what motion even meant. If this idea feels heavy, let us step gently into a more familiar comparison. Think of language. Every word you speak today is shaped by centuries of history. The word star, for example, carries sounds that drifted down through Germanic and Indo-European roots, each layer a memory of mouths long gone. When you speak it, you're not just communicating, you're carrying memory, even if you are unaware of it. In the same way, when nature speaks through light, it uses a speed that is not random, but historical. It carries the memory of the universe's first language, set at a time when physics itself was being born. There is a certain humility in this view. It suggests that reality is not just logical, but historical. It is not only about equations, but about memory encoded in constants. When we ask why the speed of light has the value it does, we're not just asking about measurement, we're asking about memory. And perhaps memory, like history, has no deeper answer than this. It happened, and we live with the trace. One might wonder, why call it memory rather than rule? The answer lies in the feeling of inheritance. A rule is enforced from the outside, like a law passed in a city, but a memory is carried from within. Your eye colour is not enforced, it is inherited. The speed of light too may be something inherited by the cosmos, a memory it carries in its fabric, passed down through billions of years of expansion and cooling. Science, of course, seeks ways to test this. Physicists look for evidence of whether constants may have shifted over time, as if to see whether memory has blurred. They peer into the light of quasars billions of light years away, looking for subtle changes in how atoms absorb light, like checking whether the handwriting of the universe has shifted between past and present. So far, the evidence is that the speed of light and the other constants tied to it remain steady. The memory has not faded. It is as sharp today as it was when galaxies were young. To make sense of this in everyday terms, think of a melody passed through generations. A lullaby sung to children is carried from mother to daughter, father to son. Over centuries the words may blur, but the tune remains, recognizable across time. The universe too has such a melody. The constants of physics are its lullabies, unchanged even as stars are born and die, as civilizations rise and fall. When we measure the speed of light, we are really listening to the universe sing the same tune it has sung for nearly 14 billion years. There is something deeply comforting about this thought. We often feel small, adrift in a cosmos that seems vast and indifferent. Yet here is a reminder that we are tied to its history, that every particle in our bodies obeys the same memory carried since the beginning. We are not separate from it. We are part of the inheritance. Our atoms, our chemistry, even the time that carries us forward, all rest upon this memory. It is as intimate as breath and as vast as the galaxies. And so, as you rest tonight, let the thought settle like a soft blanket. The universe remembers, not in diaries or songs, but in constants, in numbers that never shift, in the pace of light across the void. Just as your body carries the story of your ancestry, the cosmos carries the story of its birth. The speed of light may be less a wall and more a whisper, a preserved echo of a moment long past yet still present in every flicker of starlight. If we follow the thread further, we might ask, what was happening in those earliest instants when the memory was first written? What conditions could have carved this value into reality? The trail leads us toward the story of the universe's fiery youth, where the memory of light speed may have been set like a signature at the dawn of time. From here, the story carries us back to the very beginning, into the strange and delicate seconds when the universe first awoke. If the speed of light is a memory, then it must have been written in that first instant, when the cosmos was so young it had not yet learned to distinguish one force from another, one particle from another, even one moment from the next. It is hard for us to picture, because the scales are so unlike our everyday experience, but we can soften the image by thinking in simple metaphors. Imagine a pot of soup just placed on a roaring stove. At first, it is too hot to touch. Bubbles form and burst everywhere. Ingredients swirl in confusion, with no clear boundary between broth and steam. But as it cools, shapes emerge. Vegetables sink or float. The broth grows calm, patterns settle into place. The universe in its earliest moments was something like that soup at full boil, everything in frantic motion, nothing yet separated, all heat and energy. And then, as it expanded and cooled, patterns emerged, the laws settled, and memory was inscribed. In the very first fraction of a second, the temperature was so high that matter, as we know it, could not exist. Instead, there was only a field of raw energy. As the cosmos expanded, that energy condensed into the first particles, quarks, which later combined to make protons and neutrons, and a flood of electrons darting about like restless sparks. These particles were not alone. There were also messengers, particles that carried forces. Today we know 4 forces: gravity, electromagnetism, the strong nuclear force, and the weak nuclear force. But in that primal heat, these forces may not have been distinct. They may have been one unified chorus, only splitting into separate voices as the universe cooled. You might imagine it like a single note played on a violin string, pure and undivided. As the note lingers, it splits into harmonics, the softer echoes of higher and lower pitches that make the sound rich. The universe's forces are those harmonics. They began as one note and then separated, each taking its own role in shaping reality. And it was during this separation that constants, the speed of light, the strength of gravity, the charge of the electron were likely set. They are the tones of the cosmic chord, frozen when the music first began. Physicists sometimes describe this period as unimaginably brief, a slice of time less than a heartbeat, less than even the blink of an eye. To give a sense, the age of the universe today is around 14 billion years. The era when these constants were inscribed happened within a trillionth of a second from the beginning. A trillionth of a second is a span so small it is hard to grasp. You might try to imagine snapping your fingers then dividing that moment into 1 billion slices, and then dividing one of those slices into 1,000 more. That is roughly the scale of time when the universe's memories were set. And yet, from those fleeting instants, everything else has followed. Galaxies, stars, planets, oceans, and us. Born from rules decided in less than a blink. There is something quietly humbling in this. We live out our lives counting days, months, and years, but the blueprint for all of it was drawn in less time than we can even imagine. The constants, like the speed of light, were not chosen by us, nor by chance in the casual sense. They were carved in the cooling of the cosmos, frozen into the very structure of reality. Consider again the metaphor of cooling soup. At high heat, the broth is chaotic, impossible to predict. But as it cools, oil droplets form, bubbles burst, and patterns settle. Once those patterns appear, they remain. The soup does not revert to chaos unless we add heat again. In the same way, once the universe cooled past those first fiery instants, its constants remained fixed, a memory of the boiling state now long gone. The soup cooled, and the rules hardened. There is another image we might borrow, glass forming from molten sand. In the furnace, sand is liquid fire, flowing and unstructured. But as it cools, it freezes into glass. The patterns in that glass, the imperfections and bubbles, are locked forever into its surface. They are memories of the moment it hardened. The speed of light may be such an imperfection, though not a flaw, but a mark of history, a reminder of when reality solidified from the furnace of creation. Scientists call this idea symmetry breaking, a phrase that sounds more abstract than it needs to. Think of it instead as choices being made. When water freezes, it must choose where to form the first crystals, and those choices ripple outward. The whole block of ice reflects that initial decision. The early universe may have worked in much the same way. In its high-energy state, all possibilities were open, but as it cooled, it had to choose, and those choices became our constants. So, when you think of the speed of light, do not just imagine a number written in a textbook. Imagine a frozen crystal, formed in the cooling of the universe. Imagine a scar, a seashell, a lullaby. These are all metaphors for the same truth. The value is not random. It is a memory, a decision etched into the cosmos in its very first second. Tonight, as you lie in the comfort of your room, with the hum of ordinary time around you, try to picture that extraordinary moment. Everything you know, the stars, the atoms in your bones, the very rhythm of time, was once folded into a single storm, smaller than a pinprick, hotter than any furnace. And as it expanded and cooled, it carried forward a set of memories that would guide the future forever. The speed of light is one of those memories. It is the steady heartbeat of the cosmos, written at birth, still echoing now, every time light flickers across the night sky. From here, if we follow the thread a little further, we will begin to see how these frozen constants connect with another story. The great surge of inflation, when the universe swelled in an instant, stretching these imprinted rules across all of space. It is there, in that vast swelling, that the speed of light's memory may have been carried, stamped across the cosmic fabric like a watermark that cannot fade. The trail of clues now leads us to a thought that at first may seem unusual, the idea that the constants of nature are like fossils. We usually think of fossils as bones pressed into stone, the preserved remains of creatures long gone. They tell us stories of ancient seas, of forests now vanished, of creatures whose footsteps no longer fall. Yet in their silence, fossils preserve memory, and in a similar way, the unchanging numbers of physics, like the speed of light, may be fossils of the cosmos itself, telling the story of its first moments. When paleontologists brush sand from the curve of a shell or the imprint of a leaf, they are not looking at the organism as it lived. They are looking at a trace, a memory frozen in rock. Physics, too, invites us to brush gently against the fabric of reality and read its traces. The speed of light, the strength of gravity, the smallness of the electron's charge. Each might be like an imprint left in the cooling stone of time, recording choices made when the universe was very young. There is a phrase scientists sometimes use: frozen accidents. It sounds almost careless, but what they mean is that in the earliest instance, when the universe was seething with energy, many different outcomes may have been possible. Yet as it cooled, it froze into a particular set of rules. The accidents of that freezing became permanent, and now, billions of years later, we still live with them. They are not accidents in the sense of mistakes, but in the sense of unplanned outcomes that became locked forever, like bubbles caught in glass. Consider, for example, your own habits. Perhaps you once tried something as a child, sitting a certain way at the table or humming a tune without thinking. Over time, the habit settled in. It was never chosen deliberately, but now it feels part of you. In the same way, the universe's constants may be habits formed in its first seconds. They were not planned, but once fixed, they became inseparable from reality itself. Among these constants, the speed of light is the most famous, but it is not alone. There is also Newton's constant of gravity, which governs the pull between stars and planets, and Planck's constant, which sets the rhythm of the quantum world where particles flicker and dance. There is the charge of the electron, which tells us how atoms bond, how chemistry unfolds, how life itself can arise. Each of these values is not just a number in a book, it is a memory, a fossil, a trace of how the universe cooled and chose its path. The thought can be unsettling. If these numbers had been even slightly different, the world we know might never have formed. If gravity's pull was stronger, stars might have collapsed too quickly, leaving no time for life. If it were weaker, stars might never have ignited at all. If the electron's charge were altered, atoms might not bond into molecules, and chemistry would unravel. And if the speed of a light were not what it is, the very weaving of space and time would be different. Galaxies, stars, planets, and us. Perhaps none of it would exist. This sensitivity is often called fine-tuning, though we must be careful not to imagine a hand deliberately tuning the knobs. Instead, it is better to think of it as history. The universe froze in a way that permitted complexity, permitted stars and life, and we are here to notice it. Just as a fossilized fern is not remarkable to the stone around it, but to the creature gazing at it, so too are the constants remarkable not to the universe itself, but to us, who see in them the conditions that made us possible. We might think of these constants as DNA, the inherited code of the universe. Just as every living being carries instructions written long before it was born, so too the cosmos carries instructions written at its birth. The speed of light is one line of that code, the strength of gravity another. Together they shape the story of matter, energy, and time, and though we can read the code, we cannot change it. We live inside it, as fish live in water, as birds live in air. The poetic truth is that these fossils are all around us. Every time you switch on a lamp, you call upon the memory of light's speed. Every time you drop a stone and see it fall, you touch the memory of gravity's strength. Every breath you take relies on atoms whose bonding remembers the charge of the electron. You're surrounded, and indeed composed, of fossils of creation, not in bones or shells, but in laws and constants that have never wavered. Sometimes, scientists dream of universes with different constants. They imagine worlds where light travels faster or slower, where gravity crushes more fiercely or barely whispers. Most of those worlds collapse quickly into nothing, or expand into a thin mist without stars. Very few permit structure, warmth, and life. We're in one of those rare universes where the fossils of the beginning aligned in just such a way that we could be here, pondering them. It is a kind of cosmic luck, and also a cosmic memory. To soften this into imagery, think of a photograph album. Out of millions of possible snapshots, only a few are printed and kept. We leaf through them and remember what was. The universe, too, might have had countless possibilities in its youth, but only one was printed into reality. The album it keeps is written in its constants. And when we measure the speed of light, or gravity, or Planck's constant, we are not just doing science, we are turning the pages of that album. So as you let your body sink further into stillness, imagine yourself holding one of these fossils. Not a bone, not a shell, but a number. A memory of the cosmos carried for billions of years, untouched by time yet shaping every moment of your life. The speed of light is such a fossil, a silent witness to the first seconds of everything. And if we listen closely, we might hear in it the echo of choices made when the universe was still only an infant flame. From here, our quiet exploration now turns to the great expansion that followed those first moments, a surge called cosmic inflation, when the universe grew faster than thought, carrying these fossils across the entire fabric of space. It is within that swelling that the memory of light speed may have been stretched and set, imprinted across the cosmos like a watermark in paper, present in every corner we will ever see. The path now carries us into one of the most astonishing moments in the universe's story, a chapter so brief and yet so powerful that it still shapes the sky above you tonight. Scientists call it inflation, not the kind that makes prices rise at the grocery store, but the kind that made the cosmos itself swell in an instant, faster than even imagination could keep up. Picture a balloon held between your fingers. At first it lies slack, small, wrinkled. Then with one sudden breath, it swells outward, smooth and round, its surface racing away in all directions. Now imagine the universe itself as that balloon, not filled with air but with the very fabric of space. In a fraction of a moment, it expanded enormously, so quickly that regions once closer than dust motes were carried farther apart than entire galaxies are today. Another image might be cake batter placed in an oven. At first, the dough sits heavy and thick in the pan. Then the heat surges through it. Bubbles form and it rises, stretching and smoothing as it grows. Inflation was the universe's oven, the sudden warmth that caused everything to rise smooth and spread. What was once a seething microscopic patch of energy became a cosmos vast enough to hold every star we will ever see. Why did scientists imagine this strange growth in the first place? It began with puzzles. When astronomers looked at the night sky and the glow of the cosmic microwave background, the faint afterglow of the Big Bang, they found it remarkably smooth. Regions of the sky separated by billions of light years appear to have the same temperature, the same uniform glow, as though they had somehow shared a secret before drifting apart. But by the ordinary ticking of clocks and the steady pace of light, those regions should never have been able to speak to each other. How then were they so similar? The idea of inflation provided a gentle answer. Perhaps in the earliest blink of time, everything was once close enough to share the same conditions, like friends whispering in a circle. Then, in an instant, the circle expanded, stretching those friends across unimaginable distances. The smoothness we see today is the echo of that closeness, preserved and spread by inflation. Inflation also helps explain another riddle: why the universe appears so flat, like an endless sheet without curve. If you take a balloon and blow it up enormously, any small patch of its surface looks flat to your eyes. The Earth itself is round, but a field seems flat when you walk across it. Inflation stretched the universe so much that, from our small perspective, it looks flat even though it may curve on scales beyond our vision. This sudden growth was unimaginably brief. To describe it, scientists speak of moments so small that ordinary words fail. It lasted perhaps a trillionth of a trillionth of a trillionth of a second. During that heartbeat of time, the universe grew from smaller than an atom to larger than galaxies, and yet, despite its speed, this expansion left behind lasting marks. Like a wind smoothing sand into dunes, inflation sculpted the fabric of the cosmos, fixing conditions that would guide everything that followed. The most extraordinary part is this. Inflation may have carried with it the memory of the constants. Just as a baker spreads dough evenly across a pan, inflation spread the early conditions evenly across space. Whatever values the forces and constants took in that moment were stretched and imprinted everywhere. The speed of light, the strength of gravity, the ratios of the quantum world, all of them became written across the universe, the same in every corner, like a watermark that cannot be erased. Imagine ink dropped into water. At first, the droplet is small, its boundaries sharp, but as the water swirls, the ink spreads until every part of the glass holds the same tint. In much the same way, inflation spread the conditions of the young cosmos so thoroughly that every galaxy, every star, and even every atom you touch carries those same imprints. That is why the speed of light is the same in every experiment, in every laboratory, across all of space. The universe does not change the ink once it has been stirred. There is a softness to this story that comforts, even as it astonishes. We're used to thinking of rules as imposed, as if someone set them deliberately. But in this vision, the rules are more like the patterns left by cooling, the traces left by expansion. They are not commands, but memories. Inflation did not merely enlarge the universe, it wrote its constants into the fabric, carrying them outward like seeds on the wind. And so, when you look at the smooth glow of the night sky, or when you marvel at how light moves with perfect consistency, you're seeing the signature of inflation. You're seeing the stretched memory of the universe's first instance. The speed of light may feel like a number from a textbook, but it is also the echo of a balloon swelling, a cake rising, a fabric unfolding in the briefest of moments. As you rest tonight, you might imagine yourself shrinking back into that first instant, standing on the surface of the balloon as it swells, or riding a bubble of dough as it rises in the oven. In that moment, everything we know, atoms, galaxies, time itself, was not yet separate, but waiting to unfold. And as the cosmos expanded, it carried with it the laws and constants we still live by. The trail of thought now leads us gently onward, to wonder about the freezing of those constants themselves. Did the rapid expansion not only spread them, but also lock them in, as though cooling water into ice? Could it be that inflation pressed the speed of light into permanence, making it the memory we inherit today? From here, our story opens into a quieter but no less profound thought. Once the universe swelled during inflation, did it also settle into the rules we now take for granted? It is one thing to imagine space stretching like a balloon, smoothing and spreading conditions across the cosmos. It is another to imagine that, in that same instant, the constants of nature were pressed into place, locked as though by frost. The speed of light, steady and unchanging, might not simply be a value we measure, but the result of a freezing, an ancient moment when possibility turned into permanence. To feel this more clearly, let us return to something familiar: water. When liquid water cools, it begins to freeze. At first, the molecules wander freely, sliding past each other, shapeless and fluid. But as the temperature drops, they arrange into a crystal lattice, a repeating pattern that holds firm. The liquid becomes solid, and its shape is set. The universe, in its early moments, may have behaved in much the same way. Its laws were once fluid, its values uncertain. Then, in the cooling after inflation, those laws crystallized. The speed of light, the strength of forces, the charges of particles, they froze into patterns that remain unchanged. Imagine looking at ice formed on a pond in winter. The frost spreads outward, locking the water beneath. If you tap the surface, it holds firm, a pattern woven throughout. That ice carries a memory of the temperature at which it froze. In the same way, the constants carry a memory of the universe's earliest cooling point. They are not arbitrary. They are records, imprints left behind. Some scientists have even wondered whether light itself might have once moved faster, before settling into the speed we know today. This idea is sometimes called the variable speed of light theory. It proposes that during those earliest instants, the universe may have allowed light to rush more quickly, helping smooth out the cosmos before slowing into its present pace. If true, it would mean that the speed of light is not just a fixed number, but the final pace chosen after a brief, wild sprint. It would be like a child running across a field, dashing with all their energy, and then slowing to a steady walk they can keep forever. Even if this idea remains speculative, it highlights something important. The speed of light is not simply there, like a road we discover. It may be a settled outcome of the universe's history. Think of bread baking. At first, the dough rises and shifts chaotically, bubbles forming unevenly, but once baked, its texture is fixed. You can see in the crumb of the bread the story of how it rose, every bubble a frozen memory. The constants of physics may be the crumb of the cosmos, frozen evidence of the way it first expanded and cooled. This freezing is not cold in the usual sense. It happened in unimaginable heat, when the universe was still far hotter than any star's core. But it was cooling relative to what came before, and that cooling was enough to solidify laws. In that furnace, the constants became what they are today. And in a strange way, that means we live inside a memory of heat and expansion, preserved forever in numbers we cannot change. To ground this thought, think of pottery taken from a kiln. Once the clay is fired, it cannot return to its pliable state. Its shape, its cracks, its glaze are fixed, carrying the story of the fire that formed it. The speed of light is like that pottery. It has been fired in the kiln of the Big Bang, its value hardened, its memory carried forward. We may study it, admire it, measure it, but we cannot change it. There is beauty in this permanence. When you look at a distant star, you see light that has travelled faithfully for thousands or millions of years, never once faltering in its pace. The star may flicker, the galaxy may whirl, but the speed remains constant. That constancy is itself a gift of freezing. Without it, the universe might not be orderly enough for galaxies to form, for stars to shine, or for us to sit here pondering the quiet of the night. Of course, scientists test these ideas with care. They look for hints of whether the speed of light has ever varied, combing through the patterns of ancient starlight. So far, the evidence suggests that light's pace has remained steady. If it did once run faster, the change was long ago sealed away by inflation and cooling. What we measure today is the result of that ancient decision. In your own life, you may have moments where choices made long ago still shape your path. Perhaps a chance encounter led to a lifelong friendship. Perhaps a skill learned as a child became part of who you are. You do not live in those moments now, but you live with their results. The universe may be the same. It does not live in its first second anymore, but it lives with the choices of that second, in every photon of light, every ripple of gravity, every rule that shapes our days. And so, as you drift deeper into rest, consider the speed of light not as a wall that keeps us in, but as a memory that holds us steady. It is the universe's way of remembering how it cooled, how it settled, how it froze into permanence. Each beam of light is a reminder of that freezing carrying the same pace across space and time, never forgetting, never wavering. From here, our quiet journey turns toward the larger picture. If these constants are frozen memories, then perhaps the entire universe is still playing out rules decided long ago. It is as if a game was set before the first move, and we're all players following those ancient rules. Let us wander gently into that reflection, where cosmic laws feel less like commands and more like inheritances, guiding every star and every life that unfolds beneath them. Our quiet exploration now turns to the idea that the universe, in those first moments, was not only inflating and freezing, but also deciding. This may sound strange. How can the cosmos decide anything? It has no mind, no hand to lift, no voice to declare rules. Yet in a deeper sense, the unfolding of physical laws can be seen as a kind of decision-making, the settling of possibilities into a single path. Once that path was chosen, it has guided everything that followed, from galaxies swirling to the very beat of your heart tonight. Think of a board game before it begins. The pieces are set, the board is ready, but the rules must be agreed upon. Will pawns move one step or two? Does the knight leap in an L shape? Without these rules, play cannot begin. In the same way, the early universe laid down its rules before the game of time could proceed. The speed of light became the maximum pace of all information. Gravity became the quiet sculptor of stars. The quantum scale received its rhythm. Once the rules were written, the game began, and we are still inside that game today. This sense of rules written early is not just metaphorical, it is visible in the uniformity of the cosmos. The light left over from the Big Bang, the cosmic microwave background, is astonishingly even, like paint brushed smoothly across the sky. That smoothness tells us the rules were already in place when the universe was very young. They were not chosen later. They were there from the beginning, playing out without interruption. To imagine this, picture a group of dancers rehearsing in silence. They seem chaotic until the music begins, and suddenly their steps align. The rhythm was there, waiting, implied in their posture. In the same way, the laws of physics were waiting to be revealed, and as the cosmos expanded, the dance began in harmony. The speed of light was not an afterthought. It was part of the choreography from the start. There is also a deeper mystery in these early laws. They appear universal, the same everywhere we look. If you measure the speed of light on Earth, or near a distant galaxy, you find the same value. If you test the behavior of atoms here or in a quasar billions of light years away, the patterns match. It is as if the universe not only wrote its rules early, but also published them in every corner, ensuring no region could stray from the script. Inflation helps explain this, stretching the same conditions across all of space, like ink spread evenly through water. But the impression remains that the rules were set before the spreading, like seeds already carrying the shape of the plant they would grow into. Think of baking cookies from the same dough. You might cut different shapes, bake them in different pans, but the flavour is the same because the recipe was decided before the oven ever warmed. The Universe 2 followed one recipe, one set of instructions written early, and every galaxy and star carries that flavour still. Some philosophers and physicists suggest that these rules are not truly necessary truths, but historical outcomes. That is, the universe might have been otherwise, but this is the version that froze into being. We live inside the result. Just as ice crystals can form in many patterns, but only one appears when water freezes, so too the laws we know may be one crystallization among many possible ones. The difference is that we cannot step into the other possibilities, we can only reflect on the one we have. This thought can feel dizzying, but also strangely grounding. It suggests that reality is not a rigid edifice imposed from outside, but a history unfolding from within. The speed of light is not sacred in itself. It is sacred because it carries memory, because it is the thread chosen when the fabric first wove. Like handwriting on ancient parchment, the value is not inevitable, but it has endured. We read it now, and in reading, we connect with the earlier story of time. What makes this even more remarkable is how dependent our existence is on those rules. If they had been different, the game might have been unplayable. If gravity's strength had been altered, galaxies may not have formed. If the speed of light had not been what it is, the balance of energy and matter might never have allowed stars to shine steadily. We live not just under rules, but under very particular ones that allowed stability and life to flourish. Imagine walking into a garden where countless seeds were scattered, yet only a few sprouted into flowers. The blooms you see are the result of conditions, soil, water, sunlight, that favoured their growth. The universe is that garden, and the laws we see are the flowers that bloomed. They are the ones that survived the conditions of the early cosmos, the ones stable enough to persist. And now, billions of years later, we marvel at their endurance. It is easy to think of rules as restrictive, but in truth, rules are what make play possible. Without the rules of chess, there is no game. Without the laws of music, there is no harmony. Without the constants of physics, there is no cosmos. They are not cages but frameworks, not chains but pathways. They give structure, allowing creativity and life to unfold. The universe is not less free because it remembers its rules. It is more alive because those rules allow patterns, structures, and stories to arise. So as you lie quietly, listening to the rhythm of your own breath, remember that it is not only your body that carries memory. The universe itself carries memory, in the form of rules written early, decisions made before time had much meaning. The speed of light is one of those rules, a line written in the cosmic script, followed faithfully across billions of years. And now, the thread of our story begins to shift once again. We have seen how the speed of light may be a memory frozen in the cooling of the universe, carried outward by inflation, and set into permanence like rules at the start of a game. But how can we be sure these constants have truly never changed? To answer that, we must turn to the experiments of today. The astronomers who listen to starlight from the deep past, and the physicists who measure atoms with clocks so precise they would never lose a second in the lifetime of the universe. These are our tools for testing memory, for asking if the cosmos has ever forgotten its own rules. The trail of clues now leads us into the tools of our own age, the quiet experiments by which we try to listen to the universe's memory. If the speed of light and the constants of nature are truly fossils from the earliest moments, how can we tell? How do we know they have not shifted even slightly, whispering of change across the ages? To find out, scientists turn not only to their laboratories, but to the cosmos itself. They listen to the oldest light as though the universe has been keeping a diary in photons, waiting for us to read. Consider a night sky filled with stars. To the naked eye, it is a sprinkling of jewels, some faint, some bright, scattered against the dark. But for astronomers, those tiny points are libraries. Every star's light carries information, written in subtle lines and patterns, the way a tree's rings carry stories of summers and winters long past. Light is not only brightness, it is history. And so, by reading it carefully, scientists hope to glimpse whether the rules of physics have changed over time. The method is subtle but beautiful. When light passes through atoms, the atoms absorb certain colours, leaving behind narrow gaps in the spectrum, like missing notes in a song. These are called absorption lines, but we might imagine them as fingerprints. Each type of atom has its own unique set of fingerprints, a pattern no other atom can forge. When astronomers observe the light from distant quasars, galaxies with luminous ancient cores, they look at how that light has passed through gas clouds on its journey to us. The gas leaves its fingerprints on the light. By comparing those patterns with the fingerprints we see in atoms here on Earth, we can test whether the rules have remained the same across billions of years. It is like finding a stone tablet from long ago and comparing its letters to the language we speak today. If the letters have shifted, if the shapes are different, it might mean the rules of writing have changed. But if the letters match, it means the language has been constant. In this way, quasars become cosmic scribes, their light carrying messages across time for us to read. Imagine light leaving a quasar billions of years ago. When it began its journey, Earth did not exist. There were no oceans, no forests, no eyes to see. The light travelled endlessly, across expanding space, across shifting galaxies, until at last it met a telescope lens on a mountaintop, and within its faint glow, scientists found those fingerprints. The lines matched the patterns of atoms here and now. No change, no drift. as though the universe has been singing the same tune for billions of years, never missing a note. This kind of work is delicate. The lines are faint, the signals buried in distance and time, yet the effort itself is poetic. Scientists are like archaeologists brushing dust from fossils, only instead of stone they brush light, teasing out the shapes hidden within. They are listening to whispers that began before our planet was born, searching for hints of whether the speed of light or the constants tied to it have shifted even slightly. So far, the whispers say no. The rules remain the same. To anchor this to something familiar, think of listening to an echo in a canyon. You shout, and the sound returns a second later. If you shout again years later, the echo sounds the same. The canyon has not changed. In the same way, the light from distant quasars is like an echo from the cosmos. We listen, and the echo is steady, unchanged from one era to the next. The canyon of the universe has held its shape. This constancy does not mean the search is wasted. On the contrary, it is part of the beauty. The silence of change is itself a kind of answer. If the universe remembers, then we can trust its memory across billions of years. The photons that brush your eyes tonight are bound by the same rules as those that brushed the first atoms into existence. And so, the experiments are not failures, they're confirmations. They tell us the universe remembers faithfully. And yet, the possibility that something might one day be different lingers like a question at the edge of thought. If even one fingerprint were slightly shifted, if even one line were blurred, it would hint at a deeper story. It would suggest the constants are not fossils but evolving features, slowly rewriting themselves over cosmic time. That would open doors to mysteries we cannot yet imagine. But for now, the silence holds. The fossils remain intact. It is humbling to realize how we gather these whispers. Astronomers sit at telescopes through long nights, gazing at faint smudges of light. Computers hum as they record the tiniest changes in brightness. To most of us, the stars simply twinkle, but to them, the twinkle is a code to be cracked. They are patient listeners, like someone waiting for a faraway friend to finish a long-delayed letter. And when at last the message is read, it says, "The universe remembers." So as you drift toward rest, picture yourself not in your room, but under a dark sky. Imagine looking up and knowing that every star, every galaxy, every quasar is speaking. Not in words, but in light. Some of that light has travelled longer than life has existed on Earth, and yet it still carries the same fingerprints, the same story, the same rules. It is as if the universe has carried a notebook since its childhood, and each photon is a page, faithfully preserved, waiting for us to open it. And from here, our path carries us even closer to the instruments of precision we have built on Earth, our most careful clocks, tuned not to the ticking of gears but to the vibrations of atoms. Just as astronomers listen to starlight, physicists listen to time itself, comparing rhythms so steady they make our ordinary seconds feel clumsy. In those rhythms lies another way of testing memory, another way of asking whether the universe has ever faltered in its song. Our quiet journey now turns from the distant sky to the laboratories here on Earth, where scientists build instruments so delicate they can test the universe's memory without ever leaving home. If quasars are the ancient scribes of the cosmos, then atomic clocks are its metronomes, keeping time with a precision that humbles even the most careful watchmaker. By listening to these tiny timekeepers, we can ask whether the rules of physics are still the same as they were yesterday, last year, or centuries ago. At first thought, a clock might seem simple, a device that ticks in regular steps, marking the passing of moments. The earliest clocks used shadows cast by the sun. Later, people built pendulums that swung with steady rhythm, or gears that turned at a controlled pace. But all of these are imperfect. Shadows shift with clouds, pendulums slow with friction, gears wear down. atomic clocks take timekeeping to another realm. They turn to the quantum world, where atoms themselves vibrate with astonishing regularity, like tiny tuning forks humming a pure, unwavering note. To imagine this, think of two violins playing the same note. If you listen closely, you might notice the smallest difference in pitch, a faint wavering if one string drifts even slightly out of tune. Atomic clocks listen in the same way, but with unimaginable precision. They measure how atoms absorb and emit light, counting each vibration as though it were a beat. The atoms, guided by the constants of nature, never lose track. They vibrate billions of times each second, each vibration the same as the last, steady as a heart that never falters. This steadiness makes atomic clocks so accurate that, if one had been ticking since the birth of the universe nearly 14 billion years ago, it would not have lost more than a fraction of a second. Such perfection is not just impressive, it is profound. It means we can use these clocks to test whether the constants, the rules of the game, are still steady. If the speed of light, or the strength of the electron's charge, or the delicate balance of the quantum world were to drift even slightly, the ticking of the clocks would slip. The violins would fall out of harmony, but so far they have not. Scientists compare atomic clocks built in different places, or based on different atoms, listening for even the tiniest discord. One clock might use cesium atoms, another strontium, another aluminum. Each species of atoms sings its own note, defined by the constants of physics. If those constants were changing, the notes would shift against each other, like violin strings falling slowly out of tune. Yet when the clocks are compared, they remain in harmony year after year. It is as though the universe is a conductor keeping every instrument perfectly aligned. There is poetry in this. We are accustomed to the world's rhythms drifting. Seasons change, tides rise and fall, our own bodies grow weary with time. But these atomic clocks remind us that underneath the surface, the universe itself keeps a steady beat, a rhythm that has not changed since the dawn of creation. We measure it with our instruments, but it is not our invention. It is the universe's heartbeat, written in atoms, carried in light, echoed in every star. Think of a lighthouse shining across the sea. Ships rely on its beam to guide them, knowing the flash will come at precise intervals. If the beam wavered, sailors would be lost. Atomic clocks are our lighthouses, steady and unwavering, guiding us in time. And when we ask whether the universe's constants are the same, we're really asking whether the lighthouse beam has flickered across billions of years. So far, the beam has not faltered. The use of these clocks goes beyond pure curiosity. They're also woven into our daily lives. Global positioning systems, the invisible web that helps your phone find its place on Earth, depend on atomic clocks aboard satellites. Without their precision, maps would wander, signals would fail. Each time you check directions or track a flight, you are leaning on the universe's constancy, trusting that atoms vibrate as faithfully in orbit as they do in laboratories. But the deeper story is not about technology, it is about memory. These clocks are instruments for asking whether the cosmos remembers itself. If the rules were to shift, even slightly, the clocks would tell us. They would mark the moment when the song of atoms changed. Yet in decades of listening, the tune remained steady. This steadiness is itself a message. The universe not only remembers its laws, it keeps them with perfect discipline. And perhaps that is why these experiments feel so dreamlike. To lie in bed and imagine atoms invisible and tiny, vibrating with flawless rhythm, is to imagine a kind of lullaby woven into the very foundation of matter. Every second of your life, every breath, every heartbeat rides on that rhythm. It is not just science, it is comfort. You're carried in a world that does not forget, that ticks steadily, that sings the same note across all of time. So as you close your eyes tonight, picture the Earth surrounded by its quiet orchestra of clocks, each one playing the same note, each one in harmony. Picture scientists comparing their rhythms, finding no discord, no drift, only memory preserved, and know that beneath the flow of your own days, beneath the passing of seasons and the rise and fall of civilizations, there is a deeper constancy. The atoms keep time, the universe remembers. From here, the story leads us into the results of these great efforts. What do the clocks and the quasars together tell us? They tell us that so far the speed of light and its companion constants have not changed. The fossils of creation remain intact. The silence of change may itself be the story. The universe whispering, in its own steady way, I remember and I endure. The thread of our story now weaves together the voices of starlight and the ticking of atomic clocks. On one hand, we have light that has travelled for billions of years, carrying fingerprints from the earliest ages of galaxies. On the other hand, we have atoms humming steadily in laboratories, their vibrations measured with exquisite care. Both are instruments for listening to the universe's memory, and when their notes are compared, they tell us something remarkable. So far, the song has not changed. The experiments whisper the same conclusion. Whether we look at the faint lines imprinted on quasar light, or at the steady pulse of atoms here on Earth, we find the same patterns, the same harmonies. The speed of light remains steady, the charge of the electron unwavering, the delicate balances that allow chemistry and life unchanged. It is as though the cosmos has kept the same tempo since the beginning, never once missing a beat. Think of an ancient cathedral bell. It has rung for centuries, its tone unchanged as generations pass beneath it. The stone around it may weather, the city may shift, but the bell's voice remains the same. In the same way, the universe's constants have rung through time, their tones as clear now as they were when the cosmos was young. We may measure them with modern instruments, but what we are hearing is an ancient sound, resonant and unbroken. Some scientists have tested this constancy to incredible precision. When comparing different atomic clocks over years, they have found no drift beyond the tiniest imaginable scales, so small that in the lifetime of the universe, the clocks would still remain almost perfectly in step. Astronomers too have compared fingerprints of atoms across billions of light years. If the constants had shifted even slightly, the patterns of light would blur, yet the patterns remain sharp. The light from distant quasars and the light from nearby stars tell the same story. This silence is not disappointing. In fact, it is beautiful. We sometimes hope for surprises, for discoveries that rewrite our understanding. But there is a deeper wonder in learning that the cosmos remembers with such discipline, that across all of time it has kept its rules intact. The silence of change is not emptiness, it is a kind of reassurance, like a lullaby that never falters, no matter how many verses are sung. It is worth pausing to reflect on what this constancy means for us. Imagine if the rules did drift, even slightly. The chemistry that shapes your body might not work the same way tomorrow as it does today. The stars might burn differently. The bonds that hold atoms together might loosen or tighten. The universe would feel unstable, unreliable, like a bridge swaying in the wind. But because the constants hold steady, the world is firm beneath our feet. We can trust the breath we take, the sunlight we feel, the bonds in our cells. Constancy is what makes life possible. This constancy also gives us a way of thinking about memory. Memory is not always about change. It can also be about persistence. A photograph preserves a face not by altering it, but by holding it steady. A song recorded on tape preserves a performance not by drifting, but by staying the same. In the same way, the constants preserve the memory of the universe's birth not by shifting, but by remaining faithful. Their silence is their testimony. They have carried the same story since the beginning, unchanged, unforgotten. Of course, the search is not over. Science is always restless, always looking again, always building more sensitive instruments. Future telescopes may see deeper into space, to light even older than what we study now. Future clocks may tick with precision beyond anything we have yet imagined. If the universe's memory has any secrets, we may still find them. But so far the story is steady. The cosmos seems to remember perfectly. To ground this in something everyday, think of a family recipe passed down through generations. Each cook adds the same pinch of salt, the same stirring of spices, the same measure of flour. Over centuries, the recipe remains the same. When you taste it, you're tasting not only food, but history, unchanged, reliable, a memory carried forward in every bite. The universe's constants are like that recipe. We taste them every day in the chemistry of air, the shining of stars, the rhythm of time, and so far they have never varied. There is a quiet poetry in this thought. We often think of the universe as vast and impersonal, but perhaps its constancy is an act of care. It remembers for us, so that we may live and flourish. It holds its rules steady so that atoms may bond, so that stars may shine, so that we may gaze at the night sky without fear that its laws will shift beneath us. It is a silent guardian, carrying its memories without error. As you listen to this, perhaps you feel your own rhythm slowing, your breath steady, your body sinking deeper into calm. You're not so different from those atomic clocks, keeping a rhythm steady and unchanging. And just as your breath assures you of life, the constancy of the cosmos assures us all of continuity. We are carried forward in a universe that remembers faithfully, that keeps its rules as carefully as any lullaby. So the experiments tell us, no change, no drift. The fossils of creation remain intact. And perhaps that is the deeper story. The silence of change is itself a kind of music, the sound of a cosmos that remembers its beginning so perfectly that it has never needed to alter a note. From here, our gentle journey will step into the heart of these constants, to one particularly delicate ratio that ties together light charge and the quantum world. It is sometimes called the fine structure constant, but we might think of it instead as the universe's secret recipe. And in that recipe lies the story of how stars shine, how atoms hold together, and how life finds its place. Our quiet exploration now turns to something even more delicate than the speed of light alone. It is a number that physicists often call the fine structure constant, but you can imagine it instead as the universe's secret recipe, a ratio so subtle and yet so essential that without it, atoms, stars, and even life itself could not exist. At first glance, it may not seem so mysterious. It is just a number, about 1 divided by 137. But numbers, like melodies, can carry weight far beyond their digits. This particular ratio ties together 3 of the universe's great players: the speed of light, the electric charge of the electron, and the constant that sets the rhythm of the quantum world, known as Planck's constant. Together, these 3 ingredients make a recipe that determines how atoms hold together, how light interacts with matter, and how chemistry unfolds. If even one of these ingredients were different, the recipe would taste nothing like the world we know. To picture this more softly, think of a sauce passed down through generations, the kind that depends on just the right balance of herbs, salt, and oil. A pinch too much of one, a pinch too little of another, and the flavour changes entirely. The fine structure constant is like that balance. It ensures the universe tastes the way it does, with stars shining steadily, atoms bonding into molecules, and life emerging on planets like Earth. Imagine for a moment that the balance was slightly different. If the number were larger, atoms might not hold together as neatly. Electrons could be pulled in too tightly to their nuclei, crushing chemistry into a rigid and lifeless form. If the number were smaller, electrons might drift too loosely, atoms falling apart, unable to bond at all. In either case, the rich chemistry of life, the bonds in water, the structure of DNA, the sparkle of oxygen in your blood, would vanish. The world would be sterile, a cosmic desert. And so, this delicate ratio is not just a curiosity. It is the quiet architect of existence. Every breath you take, every beam of sunlight warming your skin, every leaf unfurling in spring, all of it depends on this balance being exactly as it is. The number may seem abstract, but its consequences are intimate, woven into your body, your life, your very awareness. Physicists sometimes marvel that this constant is dimensionless. It has no units, no kilometers per second, no kilograms or joules. It is pure, a ratio that stands outside human measurement systems. That makes it feel almost mystical, as though the universe wrote a pure number into its fabric, independent of how we choose to measure. Some even call it the fingerprint of God, though science prefers to simply call it remarkable. Whatever words we use, the sense remains. It is not arbitrary, it is essential. We can soften this with another image. Imagine building a house of cards. The balance of each card resting on another is precarious, but once found, the whole structure stands. The fine structure constant is like the angle of those cards. If it were different, the house could not stand at all. Our universe found the precise angle, and the house has stood for billions of years. The mystery, of course, is why. Why should this number, out of all possibilities, be just what it is? Why one part in 137 and not some other ratio? Did inflation and freezing carve it into place? Did the cooling of the early universe select it from countless possibilities? We do not know. And perhaps that is part of the wonder. The universe does not tell us why. It simply sings the number into every atom, every star, every moment. To ground this further, think of music again. When a string vibrates, its harmonics follow a precise pattern. If the pattern were altered, the harmony would collapse. The fine structure constant is like that harmonic ratio, the reason atoms sing in harmony rather than noise. And we, without realizing it, are listening to that harmony every moment of our lives. The warmth of the sun, the chemistry of our cells, the spark of thought in our brains, all are notes in the song written by this ratio. It is a gentle reminder that what seems abstract is deeply personal. Numbers written in physics books are not distant curiosities. They are the reason we exist, the background conditions that allow our lives to unfold. They are fossils, yes, but fossils that breathe into us every day. The fine structure constant may be a number hidden from everyday awareness, but it is also the quiet melody guiding every molecule in your body. As you drift deeper into calm, imagine this number as a recipe card tucked away in the kitchen of the cosmos. No one sees it directly, but every dish carries its flavour. Stars are the bread baked by that recipe. Atoms are the herbs stirred into the soup. Life itself is the taste on your tongue. And if the recipe were altered, the kitchen would fall silent, but it has not. For billions of years, the universe has followed its recipe faithfully, and tonight, as you rest, you're carried in that same faithful song. From here, the thread leads us to a reflection on what life itself owes to these constants. If the speed of light and its delicate companions were even slightly different, perhaps no chemistry, no stars, no consciousness would arise. Let us wander gently into that thought. What it means to live in a universe so precisely, balanced, and how wonder itself is born from that harmony. The trail of thought now carries us deeper into a question both fragile and profound. What would life look like if the constants of the universe were even slightly different? It may sound abstract, but in truth, every heartbeat you feel, every breath you take, depends on those numbers being what they are. The speed of light, the charge of the electron, the delicate ratio of the fine structure constant, all of them are woven together into the tapestry that makes existence possible. Imagine for a moment that the speed of light were just a little slower. It is not simply that light itself would lag, but that the entire weave of space and time would shift. The balance of energy and matter would be different. Stars might burn less steadily, or collapse too quickly under their own weight. Galaxies might not form into the spirals and clusters we see, but instead fizzle out before their stories could begin. On the other hand, if the speed of light were faster, the balance of energy might scatter too freely, never settling into the stars and planets we know. Either way, the gentle middle ground that permits our lives would vanish. The fine structure constant, that delicate recipe we spoke of, shows this most clearly. A change of even a small fraction would alter chemistry so thoroughly that molecules like water, carbon dioxide, or DNA might never form. Think of how fragile a soap bubble is. Shift the balance of air or soap and it collapses. Life is like that bubble, delicate, possible only within a narrow range of conditions. This thought experiment is not only sobering, but awe-inspiring. Out of all the ways the universe might have been, it became this one, where atoms are stable, stars shine for billions of years, and chemistry has enough room to weave complexity. Out of countless possible recipes, the cosmos chose one that allowed bread to rise, oceans to sparkle, and minds to wonder. To soften the idea further, imagine a piano. If the keys were placed even slightly differently, the harmony would collapse. The music would not work. But on our piano, the one the universe built, the keys are tuned so that music flows naturally. Stars are its chords, atoms its notes, life its melody. Without the constants tuned as they are, the piano would be silent. Consider also the chemistry of your own body. The oxygen that fills your lungs binds to hemoglobin in your blood because of the precise balance of the electron's charge and the fine structure constant. If that balance were different, the bond might not hold and your blood could not carry oxygen. Every breath is therefore not just a biological act, but a cosmic one, made possible by constants, chosen in the universe's earliest moments. The sun too is a child of these constants. It burns steadily, not too fast, not too slow, because the laws governing nuclear fusion depend on them. If the constants shifted, the sun might flare out violently or never ignite at all. Either way, Earth would not be the warm cradle of life we know. The fact that we live on a planet bathed in steady sunlight is itself a testimony to the balance of these numbers. And what of the stars beyond? Their light travels for millions, sometimes billions of years before reaching our eyes. Each photon that arrives carries the same memory, the same rules. Those stars exist, and we can see them, only because the constants allowed them to form and shine. When you look at the night sky, you're not only seeing light, you're seeing the fingerprints of the laws that permit life, preserved in every spark. Scientists sometimes wonder what a universe without such balance would look like. They imagine worlds with unstable atoms where matter itself cannot last, or worlds where chemistry is too rigid, unable to weave the complexity needed for life. In such places there might be stars, but no planets with oceans, no molecules with the flexibility to carry memory, no life to gaze back at the stars. These are universes of silence, where beauty flickers but never blossoms. And yet, here we are. The constants of our universe fell into the narrow range that allows breath, warmth, growth, thought. We are not separate from those numbers. We are their result. We are the melody played by their harmony. Just as a seed contains the instructions for a tree, the constants contain the possibility of life. The tree did not have to grow, yet it did. The melody did not have to be heard, yet it sings. It is tempting to ask why, but perhaps the better question is how to listen. Life itself is the listening. Every heartbeat, every thought, every dream is a way of noticing the balance, of participating in the song. We are not outside observers of the universe's memory. We are inside it, part of the story written by its constants. So tonight, as you feel your body grow heavier with rest, consider the intimacy of this connection. The constants that govern the stars also govern the bonds in your blood, the signals in your nerves, the thoughts drifting across your mind. You're not apart from the universe, but an expression of it, shaped by the same delicate ratios that have guided atoms and stars since the beginning. From here, our quiet path will carry us to a reflection on fragility. If the constants are frozen accidents, chosen in the first seconds of creation, then perhaps they are not sacred truths but fragile harmonies, preserved like a song recorded long ago. And if that is so, then all of life, every star, every breath, every dream, lives within that recorded melody, carried forward across billions of years. The trail of thought now brings us to a quiet but humbling perspective that the constants of nature, the speed of light, the strength of gravity, the delicate balance of quantum scales, might not be sacred truths carved outside of time, but frozen accidents. That phrase may sound cold, as though we're saying the universe stumbled into itself by chance. But there is another way to hear it, as history, preserved and permanent, like footprints left in wet cement that hardened before anyone could smooth them out. In the first seconds of creation, the universe may have had many possible paths. Just as water can freeze into snowflakes of countless shapes, the laws of nature could have crystallized in many forms. But the form that hardened into our universe, the pattern that froze, became our constants. The speed of light, fixed at nearly 300,000 kilometers per second, may simply be the one that emerged and endured. Once frozen, it could not be altered. We live inside that frozen pattern now, as snowflakes live inside their crystal design. To picture this more softly, think of a song recorded onto an old cassette tape. The musicians may have played with imperfections, slight variations in rhythm, a faint hiss in the background. But once the tape was recorded, those imperfections became permanent. Every time you play it, you hear them again. They are not flaws, but features of the history of that moment. In the same way, the constants of nature are not polished ideals. They are the recording of the universe's first performance, complete with its frozen harmonies. And yet, how fragile those harmonies appear when we reflect on them. If the electron's charge was slightly different, chemistry might fail. If gravity's pull were weaker or stronger, stars might not shine steadily. If the fine structure constant were nudged, atoms might never bond into molecules. The entire cosmos feels like a song that could have gone out of tune with the smallest shift, and yet against all odds, it did not. The harmonies froze in place, fragile yet enduring, like glass that has lasted for billions of years without shattering. Perhaps this fragility is not a weakness, but a source of beauty. Think of a spider's web glistening in morning dew. Its strands are delicate, easily broken, yet the web holds together long enough to catch light and shimmer. The universe is such a web, fragile in its balance, but strong enough to last for billions of years, strong enough to cradle galaxies, stars, and life. It is tempting to imagine the constants as deliberate choices, carefully tuned by some unseen hand. But the idea of frozen accidents gives us another perspective, one rooted in humility. The universe may not have chosen its rules in any purposeful sense. They may simply be the crystallization of early conditions, and yet from that crystallization arose everything: the stars overhead, the trees outside your window, the breath in your chest. Purpose or accident, the result is the same, a harmony that allows us to exist. There is a lesson in this. In life, we often think of accidents as things to regret, mistakes to avoid. But sometimes accidents create beauty. A spilled drop of ink becomes the beginning of a painting. A stumble in near conversation sparks a friendship. A wrong turn leads to a breathtaking view. The constants of the universe may be like this: accidents that froze into place, accidents that gave rise to beauty beyond imagining. Physicists sometimes speak of the multiverse, a speculative idea that there may be countless universes with different constants, each playing its own song. If that is true, then our universe is one recording among many, one frozen harmony in a gallery of possibilities. Most recordings may not be listenable, songs out of tune, structures that collapse before they can begin, but ours is one of the rare ones where the notes align, where the fragile harmonies hold. Whether or not other universes exist, the thought deepens our gratitude for this one, the one in which we live and dream. And so, when you hear the phrase frozen accident, do not hear it as cold, hear it as history, as memory. The constants are fossils, yes, but also melodies. They are fragile harmonies caught in the cooling of the cosmos, preserved like pressed flowers in a book. Each law of physics is a petal, delicate but enduring, held in place for billions of years. In your own life, you may see reflections of this. Think of a song you remember from childhood, perhaps not perfect, perhaps carrying the scratch of an old recording. Yet when you hear it, you're carried back, reminded of times and places long past. The song is both fragile and permanent, imperfect and beautiful. The universe's constants are like that, songs from its childhood, frozen into permanence, carrying their harmonies into every moment of our lives. As you rest tonight, let the thought comfort you. The world around you is not arbitrary chaos, but a harmony that has endured since the dawn of time. Fragile though it may seem, it has held together across billions of years through the birth and death of stars, through the rise and fall of galaxies, through the entire history of life on Earth, and it will continue to hold, carrying its frozen song forward into the ages. From here, the path now carries us into the wider reflection of what these harmonies mean. If the universe is a frozen melody, then life itself is part of the song. Perhaps existence is not about breaking the rules, but about living within them, listening to their music, and adding our own verse. In the next step of our journey, we will turn toward that idea, the implications of a remembering cosmos, and what it means for us to live inside its enduring song. Our quiet journey now carries us into reflection. If the speed of light is not just a number but a memory, then reality itself becomes something more than a machine of equations. It becomes a living history, a record written in the very fabric of existence. Every constant, every law, every spark of light becomes a page in that diary, preserved across billions of years. We usually think of history as something human, carved in stone tablets, painted in cave walls, or typed into digital archives. But what if the cosmos itself is the greatest historian of all? What if it keeps its own record, not in ink or photographs, but in the rhythm of its constants? The speed of light, fixed and faithful, is like a sentence written long ago, repeated with every photon that races across the universe. Gravity's pull is another line in the diary, one that tethers stars and planets in place. The tiny charge of the electron is a line too, shaping chemistry, shaping us. Imagine a diary written not in words but in melodies. The song begins in the first second, and every note carries forward. Some notes are loud, like the roar of galaxies forming. Some are quiet, like the hum of atoms bonding in your body. But the melody never forgets. It remembers its opening bars, playing them again and again in the background. That is what constants are, repeating notes in the melody of the cosmos, reminders of how it all began. This way of thinking transforms our relationship with the universe. Instead of seeing it as a cold stage on which life happens by accident, we can see it as a memory keeper, holding its past close, carrying it forward into the present. When you watch starlight, you're not just observing physics, you're reading a memory. When you breathe, you're participating in the same chemistry that was frozen in the universe's earlier seconds. You're part of the diary, not just a reader of it. There is comfort in this thought. Often, we feel small when we consider the scale of the cosmos. Galaxies are vast, time is long, and our lives are brief. But when we see the universe as a living history, we realise we are not separate from it. We are entries in the same diary, written with the same ink of constants. The atoms in your hands were written down when the laws first froze, billions of years ago. You're not an outsider gazing at history. You're history, living and breathing. To soften the thought further, picture a tree. Its rings tell the story of each year, droughts, floods, gentle seasons. The tree does not read its own rings, but the story is there nonetheless. The universe is like that tree, and we are like the branches and leaves. We grow from the rings, shaped by them, carrying them forward even without noticing. The speed of light, the strength of forces, the delicacy of quantum rules. They are the rings in the cosmic tree, and we grow from them every moment. It is striking how light itself embodies this diary. Each photon that reaches your eyes tonight began its journey long ago. Some may have left the sun 8 minutes earlier, others may have left distant galaxies billions of years ago. Yet all travel at the same speed, written by the same memory. The light is both messenger and memory, carrying forward the constant that was inscribed at the dawn of time. When you look at a star, you're not just looking at distance, you're looking at history, alive in the present. In this way, the universe is not only vast, but intimate. Its diary is not stored far away in unreachable vaults. It is written in every breath, every flicker of light, every tick of an atom's vibration. The laws of physics are not abstract ideas hovering outside reality. They are the memory of reality itself. The world holds its own story, and we live inside its pages. This perspective also changes how we think about ourselves. If the cosmos remembers, then we too are memories. Each heartbeat is a continuation of rhythms chosen long ago. Each thought is a flicker of patterns made possible by constants written in the first second. We often ask what our place in the universe is. Perhaps our place is to be a remembering part of it, to carry forward its story not only in atoms but in awareness. It is a quiet and humbling thought. The universe does not just exist, it remembers. And we, with our fragile lives and fleeting moments, are part of that memory. When you recall a childhood song, or hold an old photograph, or feel the weight of nostalgia, you are mirroring the cosmos itself. Your memory inside memory, a story within a larger story. So tonight, as you let your eyes grow heavy, imagine the universe not as empty space but as a diary spread wide. Imagine the stars as words, the constants as sentences, the galaxies as chapters. Imagine yourself as a paragraph written on one page, brief but meaningful, inseparable from the whole. The speed of a light is one of the opening lines of this diary, and it has never been erased. You are reading it now, and in your own way, you are adding to it. From here, our journey will carry us gently into the implications for science itself. If the universe is a diary, then perhaps we must learn to read it differently. Perhaps the constants are not only numbers to be measured, but stories to be interpreted, like traditions passed through generations. The question is not only what the laws are, but what it means that they remember. And so, the trail of thought leads us towards science itself, and how it may grow by embracing the idea of a remembering cosmos. The trail of clues leads us now into the practice of science itself. If the speed of light is not just a number, but a memory, what does that mean for the way we study the universe? How might our experiments, our theories, our questions shift if we think of reality not only as a mechanism but also as a living history? Traditionally, physics has been about precision. We measure constants, we refine decimals, we test again and again to see if the same number appears. The speed of light has been measured to incredible accuracy, so precise that the meter, the basic unit of distance, is now defined in terms of how far light travels in a fraction of a second. This approach treats constants as fixed truths, as foundations on which we build equations. But the metaphor of memory softens that picture. It suggests that constants are not merely imposed rules, but records of history, like recipes inherited through time. Think of a family tradition. Some traditions are rigid. The same dish is cooked the same way every year. Others change subtly. A new spice added, a new step introduced, a story retold with a different detail. The tradition remains, but it evolves, shaped by memory and circumstance. Science may need to consider the universe's laws in the same way. Perhaps some constants are fixed like stone, while others are flexible, carrying the potential to evolve slowly, almost imperceptibly. This is not just poetic musing. Some scientists genuinely speculate whether constants might shift under certain conditions, at extreme temperatures, in the heart of black holes, or across cosmic timescales. It may be that what we call constants are emergent, appearing as stable outcomes of deeper laws we do not yet understand. Like the crust of bread, they seem solid, but beneath them is a process still unfolding. If this perspective is true, then science becomes more than measuring. It becomes listening. Instead of asking only, what is the value of this constant today? We might also ask, what story does this constant tell about its past? What memory does it carry of conditions long gone? In this way, constants shift from cold numbers to voices in a conversation across time. We already see glimmers of this approach in experiments. Astronomers comparing quasar light with laboratory spectra are, in effect, asking whether the universe's recipe has changed. Physicists comparing atomic clocks of different designs are asking the same. So far, the answer is no, the recipe has held steady. But the act of asking is itself a sign of growth. It shows that science is not only about certainty, but about humility, about testing whether memory is as perfect as it seems. To make this gentler, imagine yourself walking along a shoreline collecting shells. Most are the same familiar shapes, repeating again and again. But now and then, you look for one that is slightly different, a shell with a twist in its spiral or a new colour in its stripes. That search for difference is what science does with constants. It looks carefully, over and over, to see if the spiral has changed, and when it finds none, it marvels at the constancy. If it ever does find one, it will marvel at the story revealed. This way of thinking also reminds us that science is part of the universe it studies. Our instruments, our theories, our imaginations are themselves products of the same constants. The electrons in our computers, the photons in our telescopes, the neurons in our brains, all dance to the same tune as the stars. When we measure the universe, we're not outside observers but participants, listening to a memory that we ourselves are part of. There is a deep humility in this. We often imagine science as conquering ignorance, as mastering the cosmos with knowledge. But perhaps it is more like tending a family archive, dusting off photographs, restoring old recordings, passing them down. The universe has kept its memory faithfully, and science is our way of sitting quietly and reading, page by page, what it has preserved. And perhaps the most profound implication is this: if the universe remembers, then our curiosity is not an accident, it is a continuation. Our desire to ask why the constants are what they are is itself part of the memory. Just as a child asks about the stories in a family tradition, we ask about the stories in the constants. We are not outsiders demanding answers. We are inheritors looking into our own past. So what does this mean for science? It means that exploration is not only about prediction, but about connection. It means that each measurement is not only a number, but a page in the cosmic diary. It means that even if the constants never change, we change by listening to them, by letting their constancy remind us of the deep history we share with the stars. As you rest tonight, you might picture science not as a laboratory full of machines, but as a family gathered around a table, sharing recipes, passing down songs. Some notes stay the same, others shift, but the tradition endures. The universe is like that table, and its constants are the dishes passed around. We are both the guests and the keepers of the memory. From here, the trail of thought turns toward philosophy, toward the intimate reflection that if the cosmos remembers, then so do we. Each heartbeat, each breath is not separate from the cosmic rhythm, but part of it, a living continuation of the same memory that began with light itself. The path now carries us from science into something more intimate, philosophy. If the universe remembers, if the speed of light and the constants of nature are its diary entries, then what does that mean for us? What does it mean for human beings, so small and fleeting, to live inside a remembering cosmos? To begin, let us imagine a rhythm. You hear it in your own body, your heartbeat, your breathing, the quiet pulse in your veins. Each beat feels personal, yours alone. And yet, if you step back, you realize that heartbeat is not an isolated event. It is part of a rhythm older than you, older than humanity, older even than the earth. For your heartbeat is powered by atoms, and those atoms follow rhythms set by constants billions of years ago. Every thud in your chest is, in its own way, a continuation of the cosmic tempo. There is a deep sense of belonging in this idea. Often, when we look at the night sky, we feel distance. The stars seem far away, the galaxies unreachable. But if the universe remembers, then we're not far at all. We are part of its memory. Each of us is a note in the same song, a leaf on the same tree, a sentence in the same diary. We are not separate observers looking in. We are entries in the story itself. Philosophy, at its best, helps us reframe our place in the world. The metaphor of memory invites us to see reality, not as a cold machine, but as a living history. It says, the laws are not arbitrary, and neither are you. You're written into the same history as stars and galaxies. Your breath is possible because the constants remember their values. Your thoughts are sparks because the universe has carried forward its rules. You're not an accident, you're an echo. Think of music again. A song that begins with a note carries that note forward, weaving it into chords, variations, harmonies. Even when the melody shifts, the original note is still there, part of the structure. You're like one of those harmonies. The speed of light set the opening tempo, and your heartbeat is a later variation, still carrying the rhythm. The song is not finished, and you are part of its unfolding. This way of seeing things also changes how we think about time. We usually imagine time as something we pass through, a stream carrying us forward. But in a remembering cosmos, time is not only a stream, it is also a memory book. Each page is written, and each page is preserved. When you recall your childhood, you're not just remembering personal history, you're mirroring the way the universe remembers. Your memory is a smaller version of the cosmos's memory. Perhaps that is why memory feels so precious to us. We treasure photographs, journals, stories told by grandparents. We cling to memories because they make us feel rooted, connected, enduring. The cosmos does the same, though in its own language. It remembers not through pictures, but through constants, not through journals, but through laws. It keeps its opening moments alive in the speed of light, in the strength of forces, in the delicate ratios of atoms. Our love of memory is not separate from the universe. It is a reflection of it. There is also humility in this view. If we are part of the cosmos's memory, then we are not above it, not outside it, not in control of it. We are carried by it, just as a branch is carried by the tree. Our task is not to dominate the laws, but to listen to them, to marvel at them, to live in harmony with them. This is philosophy not as abstraction, but as daily life, the reminder that we are part of a story older and larger than ourselves. And perhaps this view also offers comfort. Life is brief, and endings are certain. But if the universe remembers, then nothing is truly lost. The atoms of your body will return to the stars, carrying with them the same constants that guided your life. The memory will continue, even if your particular story ends. You are part of something that does not forget. Think of an old tree again. A single leaf may fall, its season finished. But the tree remembers. The rings continue, the roots endure, the branches grow. In the same way, we are leaves in the tree of the cosmos. We fall, but the memory remains, preserved in the laws, carried into the future. So as you lie here tonight, consider your heartbeat not only as yours, but as a continuation of the cosmic's rhythm. The same laws that set the speed of light also set the pace of your breath. You're not alone in your rhythm. You're part of the universe's heartbeat, part of its remembering song. From here, our path turns toward humility. Science may never prove that constants are memories, and philosophy may never resolve all its questions. But perhaps the mystery itself is the gift. For just as not all memories can be measured, like the feeling of holding a photograph of someone you loved, so too not all cosmic memories can be quantified. The mystery that stays open is itself part of the wonder. And so, we will drift gently into that reflection next. Our gentle path now leads us toward humility. For even after centuries of science and philosophy, even after telescopes that listen to starlight, and clocks that count the very heartbeat of atoms, we must admit, the full story remains a mystery. We can measure the constants of nature with astonishing precision. We can imagine them as memories, as fossils of creation, as frozen harmonies. But can we prove that they are memories in the way we think of our own recollections? No, not yet, perhaps not ever. And that is the beauty. The mystery stays open. Think of an old photograph you hold in your hands. The paper carries an image of someone you once knew, a moment once lived. The photograph does not explain why that smile was so warm, or what the weather was like that day, or how you felt in your chest when you stood there. It is a memory, but it does not explain itself. The constants of the universe are like that photograph. They show us what has endured. They allow us to see the continuity of the cosmos, but they do not explain why the moment was captured, or what other pictures were never taken. This is not a weakness, it is a gift. For if everything were explained, the sense of wonder might fade. It is the open questions that keep us gazing at the stars, that keep scientists awake at night, that keep philosophers writing their meditations. The universe, by holding some of its secrets close, invites us into an endless dialogue. It whispers, "Here is what I remember, but not all I know." Science thrives on this kind of openness. The most precise measurements so far tell us that the constants have not changed. But scientists continue to look deeper, not because they expect the answer to change, but because they know the search itself is part of the story. Each new telescope, each new clock, is another attempt to listen more carefully, to brush away more dust from the fossil. Even if they never find a change, they will have sharpened our sense of wonder, refined our picture of the cosmos, and deepened our appreciation for its constancy. Philosophy, too, thrives on the mystery. For philosophers, the important thing is not only whether the constants are memories in a literal sense, it is the metaphor itself, the way it shifts how we see the world. If you walk through life thinking the universe is a machine, you will treat it one way. If you walk through life thinking the universe is a memory, you will treat it another way. The metaphor shapes the gaze, even if the proof remains elusive. To soften this, think of a song whose lyrics you never fully understand. Perhaps you hum along, carried by the melody, even though the words remain mysterious. The mystery does not diminish the song, it enriches it. You sing not because you know, but because you feel. The universe's constants are like that song. They play on, steady and enduring, even if we do not fully know their meaning. We hum along with existence, adding our own harmonies, carried by a melody older than stars. And perhaps this is what it means to live inside a remembering cosmos. It means that certainty is not the goal. The goal is presence, participation, listening. Just as memory in our own lives is never complete, we forget details, we reshape stories, so too the universe's memory may be more than we can measure. But what matters is not having every detail, but living within the story, knowing that we are part of it. There is also a gentleness in admitting we do not know. Humility is a soft place to rest. When you hold a photograph and cannot recall every detail, you still feel its warmth. When you listen to a half-forgotten song, you still feel its rhythm. When you gaze at the stars and cannot explain every constant, you can still feel the wonder of their light. The unknown is not a void, it is a space for awe. So tonight, as you sink deeper into calm, let the mystery comfort you. Let the fact that not everything can be proven soothe rather than disturb. You do not need every answer to feel part of the story. The cosmos has written its memory into light and constants. We read what we can, the rest we imagine. And imagination is itself a gift, another way of remembering what cannot be measured. From here, our story begins to widen again. We have spoken of the speed of a light as a memory, but it is not the only constant that carries history. Gravity's strength, the rhythm of the quantum world, the charge of the electron, each of them may be echoes as well. Each may be another line in the diary of creation. If the speed of light is one chapter, then the universe holds many more. And in turning those pages, we may find that memory is not the exception, but the rule. The trail of our journey now widens, carrying us to a broader view. For as remarkable as the speed of light is, it is not the whole story. It is one chapter in the larger diary of the cosmos, one line in a much longer song. To treat it as the only constant that matters would be like reading a single page of a novel and thinking you know the ending. The universe remembers more than just light's pace. It remembers gravity's pull, the rhythm of the quantum world, the masses of its particles, the way charges balance in atoms. Each of these is another chapter, another verse in the story. We have focused on the speed of light because it is the most familiar. It governs communication, the reach of gravity, the limits of causality. It shapes how we see the universe, how we measure time, how we imagine the stars. But just as no melody is carried by one instrument alone, the harmony of existence is carried by many constants together. The universe is a symphony, not a solo. To make this gentler, imagine a recipe. The speed of light is the flour, essential, foundational, but flour alone does not make bread. You also need water, yeast, salt, heat. The other constants are those ingredients. Gravity binds the dough, the quantum rhythm adds bubbles of lightness, the electric charges flavour the chemistry. Together they make a loaf that rises fragrant and nourishing. The universe is that loaf, and every constant is part of the recipe. It is tempting, when faced with the immensity of these numbers, to think of them as abstract, distant. But in truth, they are as intimate as breath. Gravity is why you stay rooted to the earth instead of drifting into the sky. Quantum rules govern the warmth in your coffee, the colour of the morning sun, the sparkle in a raindrop. Electric charges hold your body together, binding atoms into molecules. These are not distant curiosities. They are the constants that allow you to be you. So the speed of light is not the book itself. It is one line of poetry in a longer collection, one strand of thread in a vast tapestry. It is profound, yes, but it is not alone. And perhaps that makes it even more beautiful, because it reminds us that the universe does not remember only one thing, it remembers many. Its diary has countless entries, each preserved since the beginning, each shaping the chapters to come. To soften the image further, think of an old quilt. Each patch of fabric carries its own history, one from a child's dress, another from a parent's coat, another from a traveller's blanket. Sewn together, they form a story larger than any single square. The constants of physics are like those patches. The speed of a light is one, but the strength of gravity is another, the charge of the electron another, the tiny quantum rhythm another still. Together they make the quilt we live beneath, warm and sheltering. This way of seeing things also prevents us from falling into arrogance. Sometimes, because the speed of light is the most famous, we imagine it as the king of the constants, the master rule. But in truth, it is one partner among many. Without gravity's strength, stars would not shine. Without quantum rules, matter would not form. Without electric charge, chemistry would collapse. The song needs every note, the recipe every ingredient, the quilt every patch. In this broader perspective, the speed of light becomes not smaller, but more meaningful. It is precious precisely because it is part of a chorus. It does not stand alone. It belongs to a family of memories, each frozen in the first seconds of the universe, each essential to the harmony of existence. The story of light's pace is remarkable, but the story of the whole family is even richer. And what does this mean for us? It means that when you marvel at the speed of light, you can also marvel at the pull of gravity that keeps you safe on Earth. You can marvel at the quantum hum that makes fireflies glow and computers work. You can marvel at the electric charges that let your neurons fire, your muscles move, your thoughts spark. Each of these is another memory, another diary entry, another fossil of creation. It also means that the universe's story is larger than any one law. If we are entries in its diary, then we are written not only in light but in gravity, in quantum rules, in chemistry. Our lives are shaped by all the constants together. We are not children of one memory, we are children of many. So tonight, as you rest, imagine the speed of light as one chapter in a book so vast you could never finish it. Imagine turning the page and finding another chapter, gravity strength, another page, quantum scales, another, charges and masses. The book is endless, but you're inside it. You're a line in its story, shaped by every chapter, carried forward by every memory. From here, the trail of thought guides us gently to wonder. If the universe remembers through all its constants, what else might it be holding? What other echoes, what other recipes, what other family traditions are hidden in its diary? Our next step will wander into that question, into the idea that beyond light, beyond gravity, beyond charge, there may be countless other memories preserved, waiting quietly for us to notice. The trail of our journey now turns to a simple but profound question. If the speed of light can be seen as a memory, what else might the universe remember? For light's pace is only one line in the diary. Gravity has its own entry. Planck's constant has another. The charge of the electron yet another still. Together they make a collection, like pages in a family album, each with its own story, each preserved since the very beginning. Let us begin with gravity. You know it as the force that keeps your feet on the ground, that tugs apples from trees, that guides rivers down mountainsides. But gravity is also the sculptor of the cosmos. It gathers gas into stars, stars into galaxies, galaxies into clusters. Its strength is astonishingly gentle compared with other forces, and yet across vast distances it dominates. Why is its strength exactly what it is? Neither too weak nor too strong. If it were stronger, the universe might have collapsed into black holes before galaxies could form. If it were weaker, matter might have drifted apart, too diffuse for stars to ignite. Its value seems finely balanced, frozen at the birth of time. Perhaps this too is a memory, gravity carrying within it the whisper of the early cosmos when its strength was set and preserved forever. Now turn to the tiny realm of the quantum. Planck's constant, named for the physicist Max Planck, defines the scale at which quantum effects appear. In everyday life, we do not notice it. We pour tea, tie shoelaces, read books, all without quantum strangeness intruding. But in the smallest domains, Atoms, photons, electrons. Planck's constant sets the rhythm of their dance. It tells particles how to step, how to leap, how to hum with energy. If this constant were different, quantum mechanics would weave an entirely different fabric. Chemistry might not hold, light might not behave as it does, life might never have arisen. So here too is a frozen memory, a decision made when the cosmos was still molten, still boiling with possibility. And then the charge of the electron, so small, so humble, and yet so critical. It is the reason atoms bind together, the reason molecules form, the reason chemistry sings. If the electron's charge were even slightly stronger, atoms would collapse inward, their electrons clinging too tightly to their nuclei. If it were weaker, atoms would fall apart, unable to hold together. The value is just right. Not by our preference, but by history, by the memory of the moment when the universe cooled and this charge became fixed. Every bond in your body, every strand of DNA, every drop of water owes its stability to this remembered value. These are only a few of the constants. There are many more, each shaping reality in ways we sometimes take for granted. The masses of protons and neutrons, the balance between matter and antimatter, the strength of the nuclear forces that hold atomic nuclei together. Each one is a page in the diary. Each one is a frozen decision. Each one is a memory. To soften the image, imagine a family recipe passed down for generations. Each household may cook it slightly differently, an extra pinch of spice here, a longer simmer there. Yet at its heart, the recipe is the same, carried from ancestor to ancestor, generation to generation. The constants are like those recipes. The speed of light is one dish, gravity another, quantum rhythms another still. Together they form the family table of the universe. We are the ones who sit at that table, tasting the flavors, carried by traditions we didn't invent but inherit. This metaphor also helps us appreciate the quiet balance of it all. A recipe can be ruined by too much salt, too little flour, too much heat. Yet when the balance is right, the dish nourishes, delights, sustains. The universe's recipe is balanced in ways that nourish galaxies, stars, planets, and life itself. We are not separate from this meal. We are part of it, shaped by the same ingredients, tasting the same flavors that were stirred into the cosmos from the very start. So what else might be remembered? Perhaps all of it. Perhaps every constant is a memory, every law a fossil of the early universe. We do not need to know why they froze the way they did to be moved by the fact that they did. Just as you can treasure a family photograph without knowing the story of the day it was taken, we can treasure the constants as photographs of creation. They are snapshots that endured, carried through time, and maybe, just maybe, the universe remembers more than we can measure. Perhaps there are constants we have not yet discovered, subtle echoes hidden in the folds of physics, waiting for us to notice. Science is, after all, a process of uncovering. Each century brings new discoveries, new pages in the diary revealed. If the speed of light was once mysterious and is now familiar, what other constants lie ahead, waiting to be read? So tonight, as you breathe quietly, imagine the universe as a kitchen filled with recipes, or a quilt sewn from many fabrics, or a family album full of photographs. The speed of light is one recipe card, one patch, one photograph. Gravity is another. Planck's constant is another still. Together they make the memory of the universe, a collection too vast for us to fully hold, but one we live inside every moment. From here, our gentle journey leads us toward a reflection on progress. For though these constants seem frozen, the universe itself is not frozen. It evolves, it grows, it changes. Stars are born and die, galaxies collide, life blooms and fades. Memory does not mean stasis. The story continues. And so let us wander into that thought, that a remembering cosmos is also a living, evolving cosmos, where memory and progress walk hand in hand. The trail of clues now carries us into a reflection both humbling and hopeful. If the constants of nature are frozen memories, fixed since the first seconds, does that mean the universe itself is frozen? Does it mean the story ended before it began, everything predetermined by those unchanging numbers? Not at all. For memory is not the same as stasis. Memory is continuity, not immobility. The constants may be fixed, but the universe built upon them is still unfolding, still alive, still writing new chapters every day. Think of a person who remembers their childhood. The memories are fixed, unchangeable snapshots of times past, but the person continues to grow, to learn, to change. The memory does not freeze them, it gives them continuity. In the same way, the speed of light, the charge of the electron, the rhythm of the quantum world, they are the universe's childhood memories, written at its birth. And yet, galaxies still swirl, stars still ignite, new worlds still form. The story continues, guided but not imprisoned by memory. Everywhere we look, we see signs of progress. Stars are born in clouds of gas, like flowers blossoming in cosmic gardens. They burn for millions or billions of years, then fade, some collapsing into black holes, others scattering their enriched elements into space. Those elements, carbon, oxygen, iron, become the seeds of new stars, new planets, new life. This cycle of birth and death is not repetition but growth, each generation carrying the memory of the last, each step adding to the unfolding story. The same is true on Earth. The constants allow chemistry to work, but chemistry has not stood still. From simple molecules, life arose. From single cells, forests and oceans bloomed. From living creatures, minds emerged, capable of reflecting on the very constants that made them possible. The speed of a light may be steady, but your thoughts, right now, are not. They're new, fresh, unfolding in real time. The universe is not done. It is still becoming. To soften this thought, imagine a river. Its bed was carved long ago, fixed in shape by the land through which it flows. But the water is always new. No two ripples are the same. The river remembers its path, but the journey is alive, never repeated. The constants are the riverbed, guiding the flow. The universe is the water, forever moving, forever renewed. This distinction matters because it helps us hold both wonder and humility. The constants remind us of the universe's past. They are fossils frozen at creation. But the stars remind us of its present, alive and evolving. Both are true, both are beautiful. We live at the intersection, carried by the fossils, surrounded by the flow. Even in the vastness of time, this truth holds. Billions of years from now, the constants will remain. The speed of light will still carry its same value. The electron will still hum with the same charge. But the universe itself will look different. Galaxies will drift apart. Stars will exhaust their fuel. New structures will emerge. The memory will endure, but the story will move forward. Just as you carry your childhood with you but live as an adult, the universe carries its beginning but continues to grow. There is a deep comfort in this, for it means that we are not trapped in repetition. Life is not merely an echo of what was, but a continuation. The constants may give us the framework, but within that framework there is infinite room for creation. Every smile, every poem, every discovery is new. The diary of the universe may have its opening written, but its later pages are still being filled, and perhaps this helps us understand our role. We are not only readers of the cosmic diary, we are also writers. With each breath, each thought, each act of kindness, we add a line to the story. The constants gave us the alphabet, the grammar, the rhythm. But the story itself is ours to live, ours to write, ours to share. Think again of a family recipe. The core remains unchanged. the flower, the water, the salt. But each generation prepares it slightly differently. One bakes it longer, another adds herbs, another pairs it with wine. The recipe is the memory, but the meal is alive, fresh each time it is made. The universe is like that meal. The constants are the recipe, unchanged. But the stars, the galaxies, the lives that unfold, they are the living flavour, different every time. So, tonight, as you let yourself sink deeper into calm, know that you are not living in a frozen world. You're living in a universe that remembers but also evolves. The constants are steady, but your life is not predetermined. It is a fresh note in a continuing song, a new ripple in a river that never stops flowing. The universe has memory, but it also has motion. It carries the past, but it writes the future. And so, from here, our journey drifts toward its gentle close. We will reflect on the speed of light once more, not as an isolated fact, but as a lullaby, a cosmic echo reminding us of where we came from. It is a soft farewell, not an end, but a pause, a reminder that we are held within a story larger than ourselves. And so, we arrive at the quiet end of our exploration. We began with a simple question: is the speed of light just a number? Or could it be a memory? A fossil of the universe's earliest moments? Along the way, we followed the trail of starlight across billions of years, listened to the steady ticking of atomic clocks, reflected on fragile harmonies of constants, and wondered about the philosophy of a cosmos that remembers. Tonight, the journey itself becomes the lullaby, a soft rhythm carrying us toward rest. The speed of light, nearly 300,000 kilometers each second, is astonishing when you think of it as motion. But as memory, it is something gentler. It is the echo of the universe's childhood, a whisper that has never faded, a note still resonating in every photon. To know this is to feel not small, but connected. The light that brushes your eyes is the same light that carries history, the same light that remembers where we came from. When we picture the universe as a book, the speed of light is one of its first chapters. Gravity, quantum scales, the charge of the electron, these are other chapters, other verses. The story is larger than any single law, and yet each law carries its own echo. The book is unfinished, but the opening lines endure, guiding every new page. And you, right now, are part of those pages. Your breath, your thoughts, your dreams, they're written with the same alphabet as the stars. To soften the image, think of a lullaby sung by a parent to a child. The song may be old, carried through generations, its melody unchanged. Yet each time it is sung, it is fresh, new, alive. The speed of light is like that melody, steady and unbroken. The universe has been singing it since its birth, and tonight, as you drift towards sleep, you are part of the listening. There is also comfort in knowing that the universe's story is not finished. Its constants may be steady, but its stars are still being born, its galaxies still colliding, its worlds still turning. The diary is still being written, even now. And though our lives are brief, we are lines in that diary, harmonies in that song, echoes in that memory. We belong. Humility is the gift the universe offers. We cannot prove whether the constants are memories in the way we remember childhood photographs. We may never know why the recipe of the cosmos turned out just so, but what we can do is listen. We can feel the comfort of constancy, the wonder of fragility, the poetry of memory. The mystery stays open, and that openness is its own kind of grace. So, as you lie here, feel the quiet rhythm of your breath. Inhale, exhale, steady as the ticking of atoms, steady as the pulse of light. Your heartbeat is not separate from the universe's song. It is part of it, a variation on the same theme, a rhythm woven into the larger memory. You are in every sense the cosmos remembering itself. And now, we close with gratitude. Thank you for walking this gentle path tonight, for letting the story unfold around you. If your eyes are still open, you may feel the weight of rest approaching. If they are already closed, you are being carried deeper into the echo of memory. Either way, the universe holds you. Its constants cradle you. Its history includes you. If you'd like, take a quiet moment to share where you are listening from and what time it is for you right now. It is always a wonder to see the gathering of people from so many places, each listening under different skies, each carried by the same cosmic memory. We are scattered across Earth, but united by light, by story, by rest. So let the thought linger, whether constant or memory, whether fossil or frozen accident, the universe is steady enough to hold you, to let you rest. It has carried its echoes for billions of years. It will carry them still, and tonight it carries you too, into quiet, into calm, into sleep. Good night, dear traveller. Sleep peacefully wherever and whenever you may be.